The volcanic sand beneath Milan Grevich's boots felt different than anything he'd experienced before. It was November 1st, 1943, and Empress Augusta Bay on Bougainville stretched before him in shades of black and grey. As a sergeant crouching behind hastily arranged defensive positions, his eyes tracked the dense jungle tree line for any indication of Japanese troops preparing to attack. What he held in his hands represented something that military regulations had never anticipated, something that shouldn't have existed anywhere except bolted into an aircraft fuselage. The weapon appeared cobbled together, assembled by someone who understood that battlefield results mattered infinitely more than following proper procurement channels. Someone had stripped an aircraft machine gun from a crashed dive bomber and fitted it with a crude bipod attachment. The metalwork still carried the acrid smell of welding torches and improvisation. 2 days later, when Japanese forces launched their assault on November 3rd, Grevich would witness this improvised weapon firing at rates that seemed physically impossible for ground-based firearms. The weapon spat rounds at velocities no standard marine machine gun could hope to match. What Grevich couldn't have known in those tense moments was that this unauthorized modification, born entirely from frustration with inadequate equipment and the desperate necessity of combat, would eventually transform into one of the most devastating infantry weapons employed throughout the Pacific War. This particular weapon would ultimately help turn the tide on what would become the bloodiest beach the Marine Corps had ever seen, a place where more American blood would soak into volcanic sand than at any other single battle throughout the entire Pacific theater. The path to that terrible moment began with a persistent problem that had plagued every Marine rifle company fighting across the Pacific Islands, a problem literally written in the blood of Marines who died while waiting for adequate fire support that arrived too late or not at all. The standard M1919. A 6 Browning machine gun, while undeniably reliable and battle-proven, was an absolute beast in terms of weight and mobility. 32.5 pounds of solid steel required multiple men to transport effectively across difficult terrain. Its rate of fire, hovering somewhere between 400 and 550 rounds per minute, provided adequate suppressive fire in static defensive positions, but lacked the overwhelming firepower necessary to quickly neutralize the kind of fortified Japanese pillboxes and fighting positions that characterized Pacific Island warfare. Marines watched helplessly as their fellow Marines fell while machine gun crews struggled to reposition their weapons, reload under fire, or bring them forward quickly enough to matter. The weapon performed admirably in defensive positions, excelled when mounted on vehicles or in carefully prepared fixed emplacements, but proved woefully inadequate for the rapid, fluid infantry assaults that defined fighting across Pacific Islands. In the dense jungles and across volcanic beaches where Marines conducted their operations, mobility meant the difference between life and death, while firepower meant the difference between victory and catastrophic failure. The M1919. A 6 offered neither quality in sufficient measure to meet the tactical demands of the battlefield. The tactical realities of Pacific combat created extraordinarily specific demands that existing weapons in the American arsenal simply could not adequately meet. Japanese defensive positions were constructed with masterful skill and tactical sophistication, utilizing natural terrain features and volcanic rock to create mutually supporting fields of fire that could devastate attacking forces. A single pillbox, if properly positioned and expertly camouflaged, possessed the capability to pin down an entire Marine platoon indefinitely. The standard tactical response required carefully coordinated action involving multiple weapon systems and unit elements. Machine guns would lay down suppressive fire while demolition teams maneuvered close enough to destroy the fortified position with satchel charges or flamethrowers. But this coordination consumed precious time, and every second of delay cost American lives. The M1919, a 6's relatively modest rate of fire, created gaps that Japanese defenders learned to exploit with devastating effectiveness. They could time their movements to occur between bursts, maintaining defensive fire even while theoretically under suppression. Marines advancing across open ground desperately needed their machine guns to deliver such an overwhelming volume of fire that defenders literally could not raise their heads to return fire without being struck. The M1919. A 6 simply could not deliver this critical level of suppression consistently or reliably. The weapon's considerable weight compounded these tactical problems significantly. At 32.5 pounds for the gun alone, plus the additional weight of ammunition belts, spare barrels, and the tripod mounting system, a complete machine gun section required at least 3 men to operate effectively under combat conditions. In the constantly shifting, fluid combat characteristic of island warfare, where Marines might advance several hundred yards in minutes only to be suddenly pinned down by hidden positions they hadn't detected, repositioning a heavy machine gun under direct enemy fire proved extraordinarily difficult and exceedingly dangerous. Individual Marines understood this fundamental problem with an intimacy born of repeated experience. They felt it in their bones every single time they watched machine gun sections struggling desperately to keep pace with rapidly advancing rifle platoons. They understood with brutal clarity that their survival in combat often depended entirely on fire support that arrived critical seconds too late, delivered with insufficient volume to effectively suppress deeply entrenched defenders who exploited every gap in covering fire. Milan Grevich understood this tactical problem better than most Marines, partly because of his background and training. Born in Minnesota on May 24, 1924, he had joined the Marine Corps, bringing with him a machinist's practical understanding of how mechanical systems worked and, more importantly, how they could be modified and improved to perform functions their original designers had never envisioned. His pre-war civilian training had provided extensive hands-on experience with metal fabrication, with understanding material tolerances and stress points, with the practical knowledge required to modify existing equipment to perform entirely new functions beyond their original design parameters. When Grevich volunteered for the newly formed Marine Parachute Battalions, he brought not just physical courage and determination, but mechanical ingenuity that would prove invaluable. The Paramarines represented an experimental concept, an elite unit designed to drop behind enemy lines and create havoc through surprise and aggressive action. They trained significantly harder than conventional Marines, fought with greater ferocity when engaged, and thought differently about tactical problems and solutions. The parachute battalions deliberately attracted Marines who actively wanted the hardest possible challenges, who sought out the most demanding training available, who genuinely believed that truly elite units required exceptional soldiers willing to push beyond normal limits. The training regime was intentionally brutal, carefully designed to identify and eliminate anyone who lacked either the physical stamina or mental toughness required for airborne operations. Those who survived the deliberately punishing selection process formed extraordinarily tight-knit units, characterized by exceptional initiative, remarkable adaptability, and a pronounced willingness to question conventional approaches when circumstances demanded different solutions. This distinctive culture of innovation would prove absolutely crucial when Grevich encountered his first ANM-2 aircraft machine gun during the Bougainville campaign. The Paramarines were actively encouraged to innovate, to identify and implement solutions in situations where regulations saw only insurmountable obstacles. Officers commanding parachute battalions understood from experience that elite troops operating behind enemy lines would inevitably face situations that no field manual could adequately address. That survival and mission success would depend entirely on the ability to improvise solutions and adapt rapidly to changing circumstances. This institutional culture created precisely the environment in which the concept of the Stinger could be conceived and developed. In a conventional Marine unit operating under standard regulations, a sergeant modifying government property without explicit authorization might very well face court-martial proceedings. In the Paramarines, that same sergeant's initiative and problem-solving might instead be rewarded with approval and institutional support for further development. The ANM-2 aircraft machine gun represented everything the M1919 A6 ground gun was not. Where the ground-based weapon weighed 32.5 pounds, the aircraft version weighed merely 21 pounds. This remarkable weight reduction was achieved through fundamental redesign of the weapon system, rather than simple material substitution or component deletion. Engineers at Fabrique Nationale had created this weapon specifically for aircraft use, where every single ounce of weight mattered critically for payload capacity and fuel efficiency considerations. The barrel walls were manufactured significantly thinner than those found on ground-based machine guns. The receiver was constructed from lighter materials, incorporating reduced safety margins that would be considered unacceptable in ground weapons. In a weapon intended for ground use, these modifications would prove catastrophic, inevitably leading to rapid barrel failure and potentially dangerous malfunctions that could injure the operator. But aircraft machine guns operated in a completely different operational environment that changed all the engineering calculations. The real revelation was the weapon's extraordinary rate of fire. Where standard ground machine guns fired between 400 and 550 rounds per minute, the ANM-2 could achieve somewhere between 1,200 and 1,500 rounds per minute under optimal conditions. This incredible cyclic rate was possible specifically because aircraft machine guns were cooled by high-velocity slipstreams created during flight. At cruising speeds, air rushing past the weapon carried away heat faster than sustained firing could accumulate it, allowing the thin barrel to sustain rates of fire that would melt a ground-based weapon barrel within mere seconds of sustained firing. The weapon had been specifically designed for rear-facing defensive positions on dive bombers and patrol aircraft, where aerial gunners needed absolute maximum firepower during brief engagements against attacking enemy fighters. In aerial combat, typical engagements lasted only seconds from initial contact to conclusion. A gunner might have only a 3 or 4 second window to successfully hit an attacking aircraft before it broke off its attack run or completed its firing pass. In those desperately brief moments, sheer volume of fire mattered infinitely more than sustained fire capability over extended periods. The ANM-2's original configuration clearly reflected its intended operational use. Spade grips designed specifically for standing gunners using both hands simultaneously, solenoid triggers activated by electrical switches enabling synchronized fire through propeller arcs, mounting systems designed to traverse quickly within the confined spaces of aircraft turrets. None of these features translated effectively to ground combat applications, but the fundamental performance characteristics offered genuinely revolutionary potential for infantry employment if properly adapted. By late 1943, aircraft machine guns were rapidly becoming surplus equipment throughout the Pacific Theater as the strategic situation evolved. As American air superiority grew increasingly dominant across the theater, as fighter aircraft mounted progressively heavier 50-caliber weapons and 20mm cannons, the 30-caliber defensive weapons gradually became obsolete for their original purpose. The strategic bombing campaign against Japan required heavy defensive armament initially, but growing fighter superiority meant bomber formations faced progressively fewer concentrated attacks, steadily reducing the operational need for numerous defensive guns. Damaged aircraft were systematically cannibalized for useful parts throughout Pacific Islands where American forces operated. Crashed planes littered beaches and jungles across the entire theater of operations. Aircraft sustaining damage beyond economical repair were methodically stripped of useful components before being abandoned or deliberately destroyed to prevent enemy salvage. Among these salvaged components were numerous ANM-2 machine guns, originally designed for aircraft mounting, but now available to anyone possessing the ingenuity to envision alternative uses. Enterprising Marines, like Private William Colby from Gloversville, New York, began recognizing opportunity where regulations and official doctrine saw only scrap metal destined for disposal. During the chaotic early days of the Bougainville campaign, Colby salvaged an ANM-2 from a crashed aircraft discovered near his unit's position. His modification approach was admittedly crude, but proved fundamentally functional in practice. He left the awkward spade grips completely intact rather than attempting to modify the firing mechanism, but added a simple bipod to the muzzle end, creating a hybrid weapon combining unprecedented aircraft firepower with minimal ground stability. When Japanese forces launched their assault against his position on November 3, 1943, Colby deployed his hastily modified weapon with devastating effectiveness that shocked everyone who witnessed it. Fed ammunition continuously by his assistant gunner, Private Edward Crumlish, he successfully repelled the enemy assault with firepower that profoundly shocked both sides of the engagement. The weapon overheated dangerously quickly without the cooling effect of aircraft slipstream during flight. It lacked any proper stock for accurate aiming, making precise fire extremely difficult. The spade grips proved awkward and uncomfortable for a prone gunner trying to maintain stable firing positions. But despite these significant limitations and ergonomic problems, the weapon fundamentally worked in combat. The psychological impact on attacking Japanese soldiers was immediate and profound beyond simple suppressive effect. Throughout the Pacific War, Japanese soldiers had grown thoroughly accustomed to the distinctive rhythmic fire patterns of American machine guns. The Browning's characteristic sound and firing cadence were intimately familiar, almost predictable to experienced troops. Attackers learned through repeated exposure to time their movements carefully, advancing during natural pauses in fire, seeking cover when fire intensified predictably. Colby's modified aircraft gun completely shattered this learned behavior and tactical adaptation. The rate of fire was so extraordinarily high that it produced not the familiar rhythmic bursts characteristic of ground-based weapons, but rather a continuous roaring tear reminiscent of heavy fabric being ripped apart at enormous scale. Japanese attackers who attempted to employ their usual movement tactics found themselves caught in fire that seemed to literally fill the air itself, that left absolutely no exploitable gaps for tactical movement, that created what felt like an almost solid wall of lead. Grevich carefully observed Colby's improvised weapon in actual combat action and immediately recognized not just a crude field modification, but rather the beginning of something potentially revolutionary for infantry tactics. The obviously crude nature of Colby's hasty conversion actually served to highlight the weapon's tremendous underlying potential rather than obscure it. If this barely modified aircraft gun with minimal adaptation could produce such devastatingly effective results in combat, Grevich reasoned, what extraordinary capabilities might be possible with a properly engineered conversion designed specifically and methodically for infantry use from the ground up? Together with Private First Class John Little, Grevich began serious work on what would eventually become the first true Stinger machine gun as a distinct weapon system. They started with an ANM-2 that had been brought ashore at Empress Augusta Bay, likely salvaged from a damaged aircraft or obtained through the extensive informal supply networks that existed between Marine ground combat units and Navy aviation personnel stationed throughout the region. The aircraft spade grips, specifically designed for aircraft gunners operating in standing positions using both hands simultaneously, were immediately obviously useless for practical infantry work in prone firing positions. A prone infantryman required a trigger mechanism he could operate effectively with one hand while simultaneously maintaining his grip on the weapon and preserving his sight picture on targets. Grevich carefully fabricated a functional trigger mechanism from available sheet metal, admittedly crude in final appearance but reliably functional in actual operation. The design was deliberately simple by absolute necessity, consisting of a straightforward mechanical linkage that effectively transferred finger pressure to the weapon's existing firing mechanism. For a proper stock, they carefully cut down an M1 Garand rifle buttstock to appropriate dimensions. The Garand stock was constructed from solid walnut, specifically selected and designed to withstand the considerable recoil forces generated by the powerful 30-06 cartridge. But walnut stocks were also precisely shaped through extensive testing and refinement to fit the human shoulder and cheek properly, offering exactly the kind of stable shooting platform that the aircraft gun completely lacked in its original configuration. Grevich painstakingly hollowed out the stock interior to accept the unique shape of the aircraft machine gun's buffer tube assembly, a demanding process requiring precision cutting and careful material removal to maintain the stock's critical structural integrity while achieving proper dimensional fit. From a Browning automatic rifle, they salvaged both the bipod assembly and rear sight mechanism. These particular components offered multiple significant advantages, extending well beyond their basic functional capabilities. Every Marine in the Pacific had already received training on the Browning automatic rifle, already possessed familiarity with its distinctive sight picture and bipod deployment procedures. Using these specific components meant the resulting Stinger would feel reassuringly familiar despite its revolutionary performance characteristics, significantly reducing required training time and making the weapon far more intuitive for Marines transitioning from standard-issue weapons. The bipod provided essential front-end stability absolutely crucial for controlling the weapon's exceptionally high rate of fire. The bar sight mechanism offered aiming capabilities distinctly superior to the original aircraft sights, which had been designed exclusively for aerial gunnery, where instinctive point shooting and tracer observation mattered infinitely more than precision, aiming at specific points. The final result was a weapon utterly unlike anything in the official Marine Corps arsenal or table of equipment. 40 inches long overall, 25 pounds fully configured with all components, belt-fed utilizing a 100-round ammunition box. The weapon looked obviously cobbled together because it absolutely was, representing an amalgamation of three completely different weapons systems held together primarily by ingenuity and desperate necessity. The aesthetic was purely functional, entirely lacking the refined lines characteristic of factory-produced weapons manufactured to exacting specifications. Weld marks were clearly visible throughout the assembly. The stock showed obvious modification and adaptation. The trigger mechanism looked improvised because it genuinely was improvised from available materials. But ultimate function mattered infinitely more than superficial form, and when Grevich conducted initial test firing of the completed weapon, the results exceeded even his most optimistic expectations based on theoretical performance. The cyclic rate remained remarkably close to the original aircraft specification, somewhere between 1,200 and 1,500 rounds per minute, depending on specific conditions. In practical combat terms, this extraordinary rate meant the Stinger could deliver approximately 3 times the effective volume of fire compared to the standard M1919A6. A 3-second burst would send roughly 70 to 75 rounds downrange toward targets. The standard 100-round ammunition box would empty completely in approximately 5 seconds of continuous sustained fire. These raw numbers translated directly into overwhelming tactical advantages in actual combat employment. Japanese pillboxes, constructed to withstand suppression from conventional American machine guns, found themselves completely unable to maintain any defensive fire whatsoever when engaged by concentrated Stinger fire. The sheer volume of rounds pouring through narrow firing ports forced defenders to take immediate cover, creating those precious few seconds desperately needed for demolition teams to advance close enough to destroy positions with satchel charges or flamethrowers. The specific Stinger that Grevich and Little painstakingly assembled on Bougainville ultimately saw no actual combat during that particular campaign. The fighting concluded before they could properly test their revolutionary creation in genuine battle conditions against enemy forces. But the completed weapon represented invaluable proof of concept, definitive validation that aircraft machine guns could be successfully converted for effective infantry use with dramatic improvements in available firepower compared to standard weapons. The Marine parachute battalions, despite their genuine elite status and extraordinarily intensive specialized training, were officially disbanded on February 29, 1944. The Paramarines had never conducted even a single actual combat jump throughout their entire operational existence. By late 1943, American strategic planners had reached the definitive conclusion that large-scale airborne operations were fundamentally impractical throughout the Pacific theater given geographical and logistical constraints. The strategic geography of Pacific operations imposed severe constraints, making airborne operations far less viable than comparable operations in the European theatre. Pacific targets consisted primarily of small islands, rather than continental landmasses, offering extensive territory for operations. The typical island objective might measure only a few miles across at maximum, offering severely limited drop zones and minimal operational space for airborne forces to operate independently before link-up. Most strategic islands were so physically small that any airborne insertion would inevitably land forces well within effective range of beach defences, completely negating the primary tactical advantage of vertical envelopment behind defensive lines. Furthermore, the enormous distances involved in Pacific operations created profound logistical challenges, specifically for airborne forces. European airborne operations could launch from relatively nearby bases with reasonable proximity, with transport aircraft returning to friendly airfields after successfully dropping troops over objectives. Pacific operations required either carriers positioned dangerously close to objectives or captured airfields located thousands of miles from major support bases. The specialized aircraft necessary for parachute operations competed directly with bombers and cargo transports for severely limited resources throughout the theater. The Navy, which ultimately controlled all strategic movement throughout the Pacific theater, demonstrated remarkably little enthusiasm for airborne operations, requiring dedication of precious aircraft and ships to highly specialized parachute units. Amphibious assault, the Navy's strongly preferred operational method, allowed concentration of absolutely overwhelming force directly at the point of attack with continuous naval gunfire support throughout operations. Airborne forces, by direct contrast, would inevitably be isolated and dangerously vulnerable until ground forces could successfully link up with them after beach landings. The para-marines were systematically scattered across the entire Fleet Marine force, their hard-won expertise and specialized training distributed among conventional infantry units throughout the Pacific. This disbandment, while genuinely disappointing to elite troops who had trained extraordinarily hard specifically for airborne operations, actually served to effectively spread the distinctive para-marine culture of innovation and aggressively creative problem-solving throughout the broader Marine Corps. Milan Grevich found himself reassigned to the machine gun section of G Company, 28th Marine Regiment, 5th Marine Division. This particular reassignment would prove remarkably fortuitous, placing him in exactly the right position to revive and systematically refine the Stinger concept for what would become the most important and terrible battle of his entire life. The 5th Marine Division was officially activated on January 21, 1944, at Camp Pendleton, California. The division was deliberately built around experienced cadres from the recently disbanded parachute battalions, inheriting not merely their personnel, but crucially their distinctive culture of aggressive innovation and pronounced willingness to challenge conventional approaches when situations demanded creative solutions. The division included the 26th, 27th and 28th Marine Regiments, with the 28th Regiment receiving a disproportionately large number of former paramarines throughout its structure. From its very inception, the division was clearly designated for a major amphibious assault operation, though the specific target remained strictly classified throughout much of their extensive training period. Throughout 1944, as the division conducted intensive training at Camp Pendleton and later in Hawaii, persistent rumors circulated constantly about their eventual destination. Some Marines speculated they would assault Formosa. Others believed firmly they were bound for the Philippines or possibly the China coast. The actual truth, when it finally emerged during classified briefings conducted in late 1944, would prove significantly more daunting than any circulating rumor. The 5th Marine Division was bound for Iwo Jima, a tiny volcanic speck in the vast Pacific that intelligence analysts confidently estimated would require approximately 1 week to secure completely. The actual battle would ultimately last 36 brutal days, demanding more Marine blood than any single battle in the entire history of the Corps. When Grevich officially joined G Company in November 1944, The regiment was deeply immersed in intensive training specifically for Operation Detachment, the official code name for the planned Iwo Jima invasion. The training regime was deliberately intense, focusing precisely on the specific tactical challenges of assaulting heavily fortified positions across extraordinarily difficult terrain. Mock beaches were carefully constructed to simulate conditions of volcanic sand. Extensive live fire exercises tested critical coordination between infantry, armor, and artillery elements. During these repeated exercises, Grevich quickly grew increasingly frustrated with the consistently inadequate performance of his company's light machine gun sections. The fundamental problem he had personally observed on Bougainville remained completely unresolved. The Marine Corps had not fielded any new weapons whatsoever that meaningfully addressed the fundamental limitations of the M1919A6. Marines were still training with exactly the same weapons, facing identical tactical constraints, accepting the same predictable casualties that genuinely better equipment might prevent or significantly reduce. During training exercises, Grevich watched repeatedly as machine gun crews struggled desperately to maintain pace with rapidly advancing rifle platoons during mock assaults. He observed suppressive fire arriving consistently too late to save Marines caught in simulated killing zones. He witnessed demolition teams pinned down indefinitely because machine guns could not deliver sufficient volume of fire to adequately suppress mock defensive positions. He knew with absolute certainty that a demonstrably better solution existed because he had personally helped build it 1 year earlier on Bougainville. The persistent memory of that first experimental Stinger, hastily cobbled together in primitive field conditions and never tested in actual combat, gnawed at him constantly. He had personally witnessed what the revolutionary weapon could accomplish during test firing. He had carefully observed Colby's admittedly crude modification devastate a Japanese attack with unprecedented effectiveness. He knew with complete confidence that properly engineered versions of the Stinger could provide Marine rifle companies the decisive firepower advantage they desperately needed and deserved. Grevich approached his company commander with a carefully considered proposal. He possessed the skills and knowledge to build modified aircraft machine guns, specialized weapons that would provide each platoon with genuinely unprecedented firepower capabilities. The company commander, simultaneously intrigued by possibilities but understandably cautious about potential consequences, fully understood that unauthorized modification of government property could easily result in court-martial proceedings. But he also clearly understood that his Marines were training intensively for an assault operation that would require every possible advantage they could obtain. The unusual request was passed systematically up the chain of command to the battalion commander for final decision. Remarkably, perhaps directly reflecting the distinctive para-Marine culture that thoroughly permeated the 28th Marines, the battalion commander granted approval. This approval came with one important caveat that would ultimately prove crucial for Grevich's legal protection. The modifications were explicitly not officially sanctioned by Marine Corps headquarters. They were not part of any approved weapons system, not listed in any official table of organization and equipment. The Stingers would not appear on any official property records, would not be subject to formal inspection procedures, would exist indefinitely in the ambiguous grey area between legitimate field modification and unauthorized equipment. But they were definitely authorized at the battalion level, a crucial legal distinction that would effectively protect Grevich from potential charges of unauthorized modification of government property. The battalion commander put his approval in writing, deliberately creating a paper trail that legitimized the entire project within the battalion's recognized sphere of authority, even though it completely lacked any higher-level sanction from division or corps headquarters. This distinction might seem like mere bureaucratic maneuvering, but it actually reflected sophisticated understanding of military authority and command responsibility. The battalion commander was essentially accepting complete personal responsibility for the entire modification program, effectively betting his career on Grevich's demonstrated ability to deliver genuinely effective weapons that would prove their value in combat. Grevich set to work immediately in Hawaii with invaluable assistance from Private First Class John Little, his trusted partner from the original Bougainville project. They systematically scoured the entire island for crashed or damaged aircraft, searched for spare parts from various aviation units, pursued any possible source of ANM-2 machine guns. Hawaii, serving as a critically important staging area for Pacific operations, hosted numerous air bases where damaged aircraft were routinely evaluated for either repair or salvage. The two determined Marines gradually developed productive relationships with Navy and Marine Corps aviation personnel, carefully explaining their innovative project and formally requesting access to surplus weapons. Some aviation units remained skeptical, questioning why ground troops needed aircraft guns. Other units proved supportive, understanding clearly that any innovation potentially saving Marine lives deserved full support regardless of regulations. The construction process was meticulous despite the crude workshops available. Each individual Stinger required precise cutting of M1 Garand stocks, careful fabrication of trigger mechanisms, exact fitting of BAR bipods and sights. The demanding work could not be rushed whatsoever. A poorly fitted stock might crack catastrophically under sustained recoil. An improperly fabricated trigger might fail at a critical moment during combat. Sights had to be precisely aligned to ensure acceptable accuracy. The trigger mechanism presented the greatest technical challenge throughout development. Aircraft machine guns used solenoid triggers activated by electrical switches, perfect for synchronized fire through propeller arcs, but completely useless for infantry work. Grevich designed a simple mechanical trigger fabricated from sheet metal and operated by finger pressure like conventional rifle triggers. The mechanism needed sufficient strength to withstand repeated use and possible rough handling in combat conditions, but light enough that a gunner could maintain precise trigger control during sustained fire. The design went through several iterations before Grevich achieved proper balance. Early versions were too stiff, requiring excessive finger pressure, making precise fire control impossible. The final design used carefully calculated spring tension, providing positive trigger feel without excessive pressure. By January 1945, as the 5th Marine Division prepared to board ships for the long journey to Iwo Jima, Grevich had successfully completed 6 Stingers. Each weapon had been test-fired extensively, systematically adjusted and refined until it functioned reliably. Testing revealed the fundamental limitation that would inevitably constrain Stinger employment in combat. The overheating problem inherent in the thin aircraft barrel simply could not be eliminated. Without the cooling effect of aircraft slipstream, barrels would grow dangerously hot after sustained fire. Grevich trained his gunners in strict fire discipline. Short bursts only, 3 to 5 seconds maximum, allowing adequate barrel cooling between engagements. This discipline was absolutely critical. An overheated Stinger was worse than no Stinger at all, as it represented wasted weight and a gunner who could have been carrying a conventional weapon. The distribution of the 6 precious Stingers was carefully considered. 1 went to each of G Company's 3 rifle platoons, providing each with organic firepower exceeding their authorized weapons. The platoon commanders received special briefings on employment tactics, learning how to maximize Stinger capabilities while managing limitations. 1 gun went to the company's demolitions section, providing covering fire for engineers attacking fortified positions. The 5th gun Grevich kept for himself, taking personal responsibility for employing the weapon he had created. The 6th Stinger went to a Marine from A Company, 28th Marines. His name was Tony Steyn, and his actions with this weapon would help him earn the nation's highest decoration for valor. Tony Steyn was born on September 30th, 1921 in Dayton, Ohio, to immigrant parents from Austria-Hungary. His parents had come to America seeking opportunity and freedom from the political instability of Central Europe. They settled in Dayton, part of the massive wave of Eastern European immigration transforming American industrial cities in the early 20th century. The Steyn family struggled financially, particularly during the devastating Great Depression. When economic hardship forced difficult choices, Tony dropped out of high school during his freshman year. This was not uncommon during the Depression, when family survival often required every able-bodied person to work. Education was a luxury many families simply could not afford. Tony found work where he could, eventually securing an apprenticeship as a toolmaker. This training proved far more valuable than any academic education he might have received. Toolmaking in the 1930s required understanding of precision measurement, material properties, machine operation, and manufacturing processes. When war came, Stein did not wait for the draft. On September 22, 1942, shortly before his 21st birthday, he enlisted in the Marine Corps Reserve. The timing was significant. In September 1942, America had been at war for nearly 10 months. The initial wave of patriotic volunteers had already enlisted. The reality of war's cost was becoming increasingly clear through casualty reports from Guadalcanal and other early Pacific battles. Stein knew exactly what he was volunteering for. Stein's recruit training at the Marine Corps Recruit Depot San Diego marked him as exceptional. The training was deliberately brutal, designed to break down civilian habits and build Marine discipline. Stein impressed his drill instructors sufficiently to be selected for Marine parachute training at Camp Gillespie. Though the Paramarines never jumped into combat, their training created Marines of unusual capability and initiative. When the parachute battalions disbanded, Stein was promoted to corporal and assigned to the 5th Marine Division, serving as assistant squad leader of Company A, 1st Battalion, 28th Marines. His toolmaker skills made him invaluable for weapons maintenance and modification. When word spread through the 28th Marines about Grevich's Stinger project, Stein's skills and interest made him a natural collaborator. Stein ended up with the 6th Stinger, the weapon that would help him earn the Medal of Honor. The journey to Iwo Jima began in January 1945 as the 5th Marine Division, along with the 3rd and 4th Marine Divisions, boarded transport ships in Hawaii. Approximately 70,000 Marines and attached Navy personnel crowded onto transports that would carry them 2,000 miles west across the Pacific. Intelligence officers explained the island's strategic importance using maps and charts. Iwo Jima sat roughly 750 miles south of Tokyo, positioned between the newly captured Marianas and the Japanese home islands. Lieutenant General Tadamichi Kuribayashi, assigned to defend Iwo Jima in June 1944, had 9 months to prepare. He recognized that Japan had already lost the war. American industrial production, military strength, and technological superiority made Japanese defeat inevitable. But the timing and terms of that defeat remained in question. If Japan could make the cost of invasion sufficiently horrific, political pressure might force negotiation rather than unconditional surrender. Kuribayashi's mission was not victory, but delay. He ordered his 21,000 troops to dig in, to burrow into Iwo Jima's volcanic rock, to create an underground fortress that could withstand even the heaviest bombardment. His men excavated 18 kilometers of tunnels, creating an interconnected network of fighting positions, supply depots, and command posts. Each position was sited to provide interlocking fields of fire. Pre-registered firing points covered every likely avenue of approach. The pre-invasion bombardment began on February 16, 1945. Major General Harry Schmidt, commanding the Marine Forces, had requested 10 days of naval bombardment. The Navy provided 3 days. For 72 hours, the most powerful naval task force ever assembled pounded Iwo Jima. Thousands of shells crashed into the island every hour. The bombardment, while visually impressive, was largely ineffective against Kuribayashi's underground fortress. February 19, 1945, dawned clear and cold. As the Amtraks churned towards shore carrying their loads of Marines, the men could see Mount Suribachi looming ahead. The Marines hit the beach at precisely 9 o'clock and immediately encountered their first obstacle. The beach was not sand in the traditional sense, but volcanic ash, black and loose. Men sank to their ankles with every step. At approximately 10 o'clock, when the beach was crowded with men and vehicles, the entire island erupted. Artillery and mortar fire fell in devastating concentrations. Machine guns fired from hidden positions. Tony Stein was the first man from his unit to move inland after hitting the beach. While others sought cover, Stein advanced, carrying his Stinger. As his platoon attempted to establish a foothold, Stein provided covering fire. The weapon's incredible rate of fire shocked both sides. When Stein's comrades became pinned down, he stood upright, completely exposed, deliberately drawing Japanese fire to himself. Once he located hostile guns, Stein could engage them with the Stinger. Stein charged Japanese pillboxes one by one, firing the Stinger from the hip in short, controlled bursts. When the Stinger ran dry, he kicked off his shoes and threw down his helmet and ran back to the beach to retrieve ammunition. He made this run 8 times during that first day, and every single time he carried or assisted a wounded Marine back with him. During these frantic hours of combat, Stein personally killed at least 20 Japanese defenders. He destroyed multiple pillboxes. The Stinger was shot out of his hands twice by Japanese fire. On February 23rd, just 4 days into the fighting, a patrol from the 28th Marines climbed Mount Suribachi and raised a small American flag on the summit. Hours later, a larger flag was raised. Associated Press photographer Joe Rosenthal captured that second raising in what would become the most famous photograph of World War II. But the photograph created a misleading impression that the battle was nearly over. Tony Stein had been wounded during fighting on Suribachi's slopes, injuries serious enough that he was evacuated to a hospital ship. Aboard ship, Stein learned that his company was heavily engaged. Despite his injuries, despite being legitimately evacuated, Stein left the hospital ship and returned to his unit. On March 1, 1945, 10 days after his Medal of Honor actions, Tony Stein volunteered to lead a 19-man patrol. The patrol moved forward carefully. Stein located one pillbox and engaged it with the Stinger. But as Stein concentrated on that target, fire from another concealed position found him. A Japanese sniper acquired Stein in his sights and fired a single shot. Tony Stein, 24 years old, fell dead in the black volcanic sand of Iwo Jima. The battle officially ended on March 26, 1945. Of the 21,000 Japanese defenders, only 216 were captured alive. American casualties were staggering. The 3 Marine divisions suffered 6,821 killed. Another 19,217 were wounded. More than 800 Americans died for every square mile of Iwo Jima's volcanic sand. The recommendation for Tony Stein's Medal of Honor began with his company commander's initial report. Fleet Admiral Chester Nimitz reviewed and approved. Stein's Medal of Honor received 15 endorsements, the most of any award in the Iwo Jima campaign. The citation praised his conspicuous gallantry and intrepidity. It described his personally improvised aircraft-type weapon, making it perhaps the only Medal of Honor citation that explicitly references an unauthorized weapon modification. Exactly 1 year after his heroic actions, on February 19, 1946, Tony Stein's widow Joan received his Medal of Honor at the Ohio State House in Columbus. Joan was 24 years old, the same age Tony had been when he died. The ceremony was dignified and solemn, but it could not fill the void left by Tony's death. After the battle, the 6 Stingers disappeared from historical